And then today is my pleasure to introduce Hermann Staude. Hermann is a leading expert in moth fauna of Southern Africa and is the author of 75 scientific articles and reports on the subject. He did say to me, please don't say this, just tell them that I'm a bush monkey who loves being outdoors. But I think it's only right that we give him his proper dues. He is the founder and project leader of the Caterpillar Rearing Group, a citizen science project of the Lepidopterist Society of Africa, and is a keen photographer of the Lepidoptera. And Southern African moths and their caterpillars are at a discount at the Kirstenbosch Botsok for the week of the talk. So without further ado, Hermann, over to you. Thank you so much.
Hi, Brett. Thank you very much for that introduction. And hi, everybody else. I can't see you. I hope you can see and I hope you can hear me. So without anything further ado, I want to get into this talk. And now it's
just click on it once on the screen.
On the screen once.
And then your arrow.
There we go. Okay. Yeah, I must just get rid of something else here. Why is this not working? Okay. Right. To start off with, moths are, and let's call them Lepidoptera, are really one of the mega diverse fauna of Southern Africa. And it's often very difficult to actually understand mega diversity. It's easy to say 10,000 or 20,000 or something like that, but to actually envisage that is not that easy. We have 11,803 Lepidoptera described from the subregion. And if you would take those names in an 11 font and you would type them next to each other in one long list, then just the list of those species will cover the length of 3 rugby fields. And if you try and compare them with vertebrate fauna, then you will see that the Lepidoptera alone make up more than 5 times the diversity of all the vertebrate fauna in Southern Africa. So if somebody would ask you to do a talk on all the vertebrates of Southern Africa, you would tell them they're quite mad. How can you fit that into a 3/4 of an hour talk? But in fact, if you want to do this with moths, you need to do 5 times that amount. So it's still got that problem. The Lepidoptera, the phylogeny of the Lepidoptera have been studied for a long time now. And with the new molecular methods, we really are beginning to understand them much better than previously when we had to do with phenotypic characters and try and work out the phylogeny of this mega diverse group. If you look at this representation by Mitter et al., then you will see that at the bottom, the Lepidoptera have split off from the Trichoptera, and there are about 160,000 species described worldwide. But if you go up the ladder, then you will see this thing called Glossata, and Glossata is, from the fossil record, the oldest Lepidoptera fossils that we know are actually scales of Glossata, and they are about 180 to 190 million years old. We really don't know how old the really primitive ones are and when the Lepidoptera started to appear. If you move up this ladder again, then you will see the Ditrichia. They are the main first clade with 152,000 species. And then 144,000 of them are in the Apoditrichia, which was the next major split. And then you have the Optectomera with 107,000 of those species. And then right at the top, you will have the Macroheterocera, which are really the most modern of moths, and they alone make up half the moth fauna of the world. So if you take that into the Southern African context, that we have 46 superfamilies represented here, worldwide. We have 30 superfamilies here with 90 families. And our fauna comprises about 6.8% of the world's Lepidoptera fauna. It is probably a lot more because we have so many undescribed known species. So when I prepared this talk, I thought, which of these 11,000 species must I actually show you so that you can have an idea of the biodiversity there is. And after thinking about it for a while, I thought, no, if I leave things out, then I misrepresent the Lepidoptera. So I'm going to take you to the edge of your comfort zone. I'm going to ask you to sit on the edge of your seat and try and keep up with me. And we will, in the space of only half an hour, run through all the major groups. And I know that I'm going to lose you along the way because this is information overload. But when that happens, just sit back, relax, and enjoy the form that you will see coming onto your screen. I apologize for that. And if you don't leave me by the end of the talk, then I must congratulate you. This is just a graph of the Southern African Lepidoptera. What is interesting here is that 80% of our fauna are vested in only a few large superfamilies. You will see the Bombicoidea, the Gelechioidea, the Geometroidea, the Noctuoidea, the Papilionoidea, and the Pyrroloidea. The Papilionoidea, most of them are what you would traditionally call butterflies, but there are some moths in there as well. And you will see they sit here in between all of the rest of the diversity. I'm going to run through all of these and show you representatives of the major groups that exist in Southern Africa. So that is just a graph to show again how some families are virtually only a few species, and you have these mega diverse families at the top with the Erebidae tops, Geometridae second, Noctuidae, etc. So this is just a list again to show you where we're going with this. And we will start with the Noctuidae, which are deemed to be the most modern of moths, with 983 species recorded. Here you see those moths you don't really like very much. These are the cutworms and the armyworms. The cutworms are notorious in your garden because they like soft tissue, and they will feed on any plant with soft tissue. Their caterpillars actually hide in the ground at night, and they will come up and feed on soft tissue. The armyworms are armyworms because they have a symbiosis with the microgut bacteria, which allows them to feed on just about anything because these bacteria detoxify the food source. Then we have the grass owlets, which is a huge group in Southern Africa. You will find them everywhere, and you can hardly go to a light without seeing them. And they all feed on various types of grasses. Then some specials in the Noctuinae are the cherry spot moth, which is very well known to so many people. And then, of course, the Amaryllis borer as well. This is probably Helicoverpa armigera, the African bollworm, is probably the most notorious of all moths. It is also polyphagous. It feeds on virtually anything, but it feeds only on soft-tissued plants. And everybody would have seen this. This is the caterpillar that is the most sent to us in the caterpillar rearing group. Then you have the Heliophinae. These are rather pretty little moths with lots of pinks and orange and even golden sheens on their wings. Then we have the paints or the cuculinae. These are rather peculiar that their caterpillars are very colorful, and that's why they call them paints. Very popular, especially amongst the young people when they do caterpillar rearing. Then we have the Agaristinae. These are colorful moths. They have become diurnal because they sequester toxins from their host plants, and therefore they have all these beautiful warning colors to warn their predators that they are indeed toxic. These are more Agaristinae. This is Brephos festiva, which is very common over most of the country, where it feeds on Cohotia and other Rubiaceae that are toxic. Then we have the Acronictinae, the dagger moths, because they have these dagger-like markings on their wings. They are very well represented in the new tropics, but we also have a few of them here as well. The Acontinae are moths that I'm sure most of you have already seen. The adults mimic bird droppings, and when they sit on these leaves, they really do look like bird droppings. I have on several occasions went for something and then it was not a moth, it was actually a bird dropping. They have colorful caterpillars and they feed mainly on Malvaceae. Here are some more examples of Acontinae. You can see the caterpillar on the bottom right being really quite spectacular. Then you have the Plucinae, another subfamily of noctuids that are really common. Many of them are polyphagous and they will also feed on soft-tissued plants. So they often feed on the weeds in your garden and other soft-tissued plants. They are extremely important pollinators because of their abundance in all biomes. In fact, a lot of the pollination research that's going on now, people send me moths for identification in their pollination research, and almost the majority of them are actually Plucinae. As you can see, they're actually queuing up on the flowers. And if you put a light out at night in autumn, you will find literally thousands of them coming to your lights. Then we have a small subfamily, the Bryophyllinae with Tryphia and others. These are rather cryptic, smaller moths but they have these sort of lichen-like camouflage colors. The Bagasaurinae are quite well-known moths, and they also feed on Malvaceae, and they are a very important control mechanism for invasive Malvaceae weeds like cedar, etc., which they consume in rather large numbers, controlling them. Then we have something called the Charadrian assemblage. We still don't really understand their phylogenetic relationships very well, but they are a diverse group with amazing caterpillars and adults, and something you can really lose yourself into. On the right, at the top, you have a caterpillar that exudes tiny droplets of a sticky fluid, and at the bottom is the adult from that caterpillar that is a perfect twig mimic. So that was the Noctuidae. So now we're coming to the largest family, the Erebidae. You can see there are a lot of subfamilies in the Erebidae, the largest being the Octinae, the tiger moths, and then the second largest, the Boletobinae, tiny little moths. But let's get into that because we don't have much time. The tiger moths or the Octinae are rather colorful moths, and they also display warning colors, but most of them have remained nocturnal. And the reason for that is that they have developed an audio system where they actually give off a sound to warn bats that they are toxic and they should not be eaten. And that allows them to remain nocturnal. And therefore also the warning colors are on the outside of the wings, which protects them during the day against diurnal predators. In the center at the bottom, you will see a male displaying its abdominal androconia. This is something very special to the Octinae, and some of these androconial systems are sometimes bigger than the moth itself. In the right, you will see one, when they get disturbed, they actually exude a very foul-smelling sap to also further deter predators. These are just some more examples of common woolly bears or Octinae. One of the things about Octinae is that they are specialist polyphagous species. They need to feed on many different plants for different needs. And therefore, you will see them walking all over the place, and hence they are called woolly bears. Here are some more tiger moths. The crimson speckled footman at the top is very well known and seen everywhere. The males actually gather toxins which they need to they need to accumulate in order to mate to the females. They actually transfer these toxins to the female, and she coats her eggs with these toxins, and that prevents the eggs from being parasitized. And many of these species have similar, rather intricate survival strategies. Then we have the footmen. It says there are 164 species, but there are more than double that we know of, but are still undescribed. They're a complex group, and they feed on lichens. And you will always find them in habitats where lichens are common. The one on the top is an exception. They actually feed on algae, and they are very common in forests where they will forage on large leaf trees, but they don't actually feed on the leaf. They keep the leaves clean from the continual algal growth on these trees. Then we have the Centomini, the so-called handmaidens. These are pretty little diurnal moths. They fly during the day, and they mimic wasps and things like that. They have rather intricate mating behavior where several males will converge on a female, and they will actually fight on top of the female to be the first to mate, which is rather unusual. Then we move over to the Boletobiinae with 305 species. These are super common moths, and in the drier areas of Southern Africa, if you would put out a light, they are by far the most abundant moths that you would find. Even if you go in the middle of the Namib Desert at Bloedkoppie, they will be absolutely abundant, and one wonders how they survive in these places that sometimes do not get any rain for many, many years. These are more Boletobiinae, the genus Eublema, which is 99 species in Southern Africa. The caterpillars of these moths are actually normally live concealed. They will live concealed within flowers, or they will make little nests like the one at the bottom left, where they use the hairs of the Solanum host plant and cover themselves. The one on the top actually feeds not on plants, but on the cockets that feed on the plants. And they will use the cocket rests and cover themselves in that. There are actually quite a number of species that have developed to feed on the cocket rather than on the plants themselves. And then we get to the Erebinae, the Erebidae proper, with 291 species. These have amazing patterns on their wings, and you cannot help but just sit back and wonder how that all these patterns actually develop, each one with its own intricate pattern, and the diversity just does not stop. The one on the top right is the commonly known as the peach moth. It's got nothing to do with peaches, and it's common in our coastal forests. It has become diurnal as well. A lot of the Erebinae have caterpillars that are extremely well camouflaged. If you look at the one in the middle, at the left in the middle, then you will see it feeds on Senegalia trees, and that thorn on its back mimics exactly the thorn that you would find on the tree. And in nature, the caterpillar will always sit the right way up so that the thorn does not point in a different direction than the natural thorns. Then we get to the tussock moths, the Lamantrinae, with 239 species in Southern Africa. These are well known because they have very fine setae, very fine hairs, and these come off quite easily, and they will often induce an allergic reaction in people when you rub against them, and they've even known to cause an allergic reaction in cattle when they consume too many of them. They are mostly polyphagous, and they feed on many different plants. One aspect of them, that many of them, the females, are actually wingless. The one on the top in the center, that is actually the female moth. It is really only an egg sac, and it will just come out of the pupa and just lay the egg spontaneously. Because they are polyphagous, they don't mind where they lay the eggs. Caterpillars will disperse and feed on virtually anything. Then we have the Kelpinae with 143 species. They have sort of elongated palpi that are curved up, and a lot of them are well known. They are these underwing moths. You see the one here on the right is a huge moth of a wingspan of maybe 15 centimeters, and it's got these orange underwings. They are quite well known in the tropical parts of Southern Africa. Here are some bizarre caterpillars of some of these Kelpinae. The dice moths, the one in the middle, these are called dice moths. There are a number of different species because they have these dice-like markings on the wings, and their caterpillars have these extremely elongated, flattened setae, the function of which we really don't understand yet. Then we have the hieroglyphics moths, the Anobinae. They have these hieroglyphic type marks on their wings. They are usually diverse, and a lot of them remain undescribed. Caterpillars are rather green and elongate, and they feed on various mimozoidea. Then we have Herminae, 24 species in Southern Africa, but many, many more undescribed. Actually, recently, quite a number of them actually got described. The caterpillars of these things don't feed on fresh plants. They feed inside the leaf litter on dry plants, and therefore they are restricted to places where there's sufficient moisture for them to feed on the dried leaf litter. Then we have the Aganainae with 12 species, the snouted tigers. They are rather not a small group, but most of them they feed on Carissa, most of them, and they have warning colors. They've become toxic. The one in the center, Sotus speciosa, feed on ficus species, and at the bottom left there's a caterpillar. And what makes them interesting is that these caterpillars actually cut off the vein on the leaf before they start feeding to prevent the sap from reaching them. And then there are a number of other smaller subfamilies within the Arabidae. The one on the left is interesting, Hypocala, because the caterpillars are green because they live in a shelter from folding the leaf, but they pupate in the soil. So in that short time, the day or so before they pupate, in a pupation phase, they turn completely black and orange. so that they can have a warning color just to migrate from their shelter on the plant down into the soil where they will pupate. It's an extremely short duration. The Pangraptinae are interesting because they have false heads. You can see at the bottom here are the false eyes and antennae. And there you always have this false tail. And this is to divert the predator's attention away from the head. And very often they escape predation. And you see many of them that are tailless. And then in Erebidae, like in many other groups, there are always a few that we have no idea where they fit in. We really don't know. And here are just some examples. So up till now, I've covered only the Erebidae and the Noctuidae. So we are still busy with Noctuoidea. So I hope I haven't lost all of you yet. So we will continue with this roller coaster ride through the moths of Southern Africa. The Notodontidae are rather interesting. They're the prominent moths. They often have this play dead posture where if you handle them, they will just fall down and play dead. They are very lethargic in that sense. Their caterpillars are quite bizarre. Many of them have extreme appendages like this fork-tailed one, or they will have colorful eyes, etc. And the diversity of caterpillars are just quite amazing. Here are a few more examples. This one doesn't look like a caterpillar at all, with this flattened, upturned tail. Here we have some more Notodontidae. The one on the bottom right looks like a broken twig. The Clostera are quite common in the Cape because they feed on protea. And here's another one. You can see this extreme tail, this very twig-like caterpillar. And here are more of the ones with these forked tails. This one is quite spectacular with these turned ends of the tail. And then we have the subfamily Thaumetopuinae, the so-called processionary moths. They are interesting that most of them, the caterpillars, when they migrate from one host plant to another, or they migrate to a place to make their nests for pupation, they actually walk on the ground in a long column, one after the other. And I'm sure many of you have seen those things. Often you will see them cross a road. And if you drive over them, then they will just simply repair and become a column again. But not all of them do this. The one on the top, Parafleps singularis, does not do this, although they are gregarious on the plant. So now we will move on to other Noctuoidea families, which are rather smaller. You have the Nolidae, which are dominated by Nolinae with 72 species and Chlorophoreinae with 67 species. The Nolinae are rather small moths, but they are conspicuous and they're well represented in all biomes, terrestrial biomes. They look like little fighter jets, and they always have this pointed snout. The caterpillars are quite bizarre and very diverse and extremely interesting, as you can see with this Meganola at the top. The one on the bottom is really interesting because when they change instars, they retain the old head shield and the next old head shield. We call this the totem moth, and the smaller one and the smaller one. So they have this whole totem pole of old head shields on top of their head. It's probably some sort of a survival mechanism. The Chlorophoreinae are extremely common in bushveld areas where they feed mostly on Combretaceae, but also on some on Malvaceae. Some more Nolinae with their caterpillars. Then you have the Eariadinae. These things are very common, and you will find them even in town and in the most transformed habitat, because they are also malvasive feeders, and they really do well on exotic weeds, where they probably become a vital part of the new nature which is developing in these transformed habitats. Then we have the turntails, the Utilidae, with 48 species. They are quite bizarre moths. They always turn their tail up, and some of them to the side, and they have these bizarre forms. They actually purposely become asymmetrical, probably as a deterrent to predators. The caterpillars are rather slug-like, and some of them have developed quite intricate colors, and rather warning colors, but the moths remain cryptic. We don't really understand why this is like that. So, you must be wiping your head by now. How is this going to end? So we've just done one superfamily, the Noctuoidea. So now we will move on to the Bombicoidea, which include the Stingidae, the hawk moths, and the Saturnidae, the emperor moths, and a number of smaller families. We have the Bombicidae. The most famous member of the Bombicidae is Bombyx mori, which is the silk moth that everybody knows and everybody has been rearing. We have our own little silk moths, Racinoa species, and the caterpillars look very similar to the standard silk moths, but they feed on ficus species. We have a rather special one, the Bromaidae, which is Spiriopsis comma. It has quite a bizarre stick looking like caterpillar, and is quite common in our forests. Then we get to the monkey moths, or the Eupterotidae. These are called monkey moths because the nocturnal monkeys, they really like the nachapis. They really like these moths. And when these moths come out in their numbers, they will consume them. And you just see all sorts of wings all over underneath the trees that they have been feasting on these things. They have rather hairy caterpillars, and a lot of you have seen them when they walk all over the place, and they're often confused with woolly bears, but they are actually quite unrelated. You have the Fialas. They feed on asparagus and on different types of asparagus. And many of them will become quite abundant in our dry areas. And sometimes in the Karoo, your lights will be swamped by these beautiful little things. This one has become diurnal, and it's quite interesting that they feed on grasses, and the female lays its eggs in the afternoon where there will be no males flying, and the males only fly early in the morning in full sunshine where they look for females. So you have this distinction that the males do not fly when the females are in the business of laying eggs. Then we get to the leopard moths, the Lasiocampidae. There's a very small subfamily of Cape endemic moths, of which this is one. The Bombicomorpha caterpillars are actually very well known and often seen in your gardens and in parks because they are gregarious and they feed only on Cercia trees. There has been some evidence to suggest that they are most abundant in autumn, and they will defoliate Cercia trees. And this process actually improves it for the tree itself. And trees that have been defoliated tend to grow better than those that have not been defoliated, because the process of transforming the leaves into frass increases the efficiency of the nutrient cycle. Then you have Bombycopsis with many different species that you find everywhere in South Africa. You have Anadiasa, which are gregarious caterpillars. And then you have the Streblotes, which, by the way, a lot of these caterpillars you should never handle because they have extremely urticating hairs. Then you have Mesocheilus, you have Monticola at the top. The one at the bottom is now being described and will have a name in a month or two's time. And that is actually the common caterpillar you see crossing the roads in their thousands in Namakwaland in the flower season, early in September. Everybody always sees these caterpillars and wonder what they are. It's this species and it is still undescribed. Then you have Gonometa postica, the African silk moth. There have been many attempts at trying to utilize the silk, but of course these urticating hairs are very difficult to separate from the silk. So they've not really been successful in doing that. Then you have the Cape Leopard moth, Eutrichia capensis, and then other species, Obscura and Bifasciata. They are interesting that the caterpillars congregate during the day on tree trunks. You can see this is a mass of caterpillars. And they actually react to sound. So if you clap your hands, they will all react at the same time. And they form a gregarious defense mechanism by being bunched together like that. At night, they will all go up into the tree, feed on the foliage, and they will come back and rest on the tree again by day. This is just an egg of a Lasiocampa to show you an example of a Lepidoptera egg. Here are some more leopard moths, interesting caterpillars. Many of them will actually have the hindwing protruding away out from the forewing, and you will see here, and this one is an example, they have androconial hairs, and this is where they actually emit pheromones for mating. Then you have Philotherma. These are rather common in large parts of South Africa, and again, these caterpillars in autumn, you will find them walking all over the place. By that time, they would have finished feeding, and they're looking for a place to pupate. And now we come to the emperor moths. These are the large showy moths that everybody sees quite easily. Whenever you get one with these large eye spots at your light, then everybody gets excited about this. And they are actually normally quite rare moths. They're called the Saturnidae because of the rings that they have on their wings that remind you of the planet Saturn. These are also the largest moths in Southern Africa. This one is Argema mimosae. It is sort of the African moon moth. You can see they have these large tails. The function of these tails is multiple. And what they do is they vibrate the tails and they actually deflect the bats away from the body, and the bats will react and go to the sound of the tails. In addition to that, they have special scales on their wings to minimize the sound that the wings make and direct the bats to the tails. Here are some more Saturnidae. They will normally rest with the eyes hidden, and when they are disturbed, they will lift the front wings, and you are all of a sudden confronted by this creature with these big eyes. And that gives them just enough chance to actually escape predation. Here are some more examples. More examples. The one on the left, Euchroa trimani, as you can see, has become diurnal, and it is confined to Namakwaland and southern Namibia. These are the Mopani moths, which are very famous because they are used, the caterpillars are often so abundant that they are actually being dried and eaten by a lot of the local people. One myth is that they feed on mopanis, and of course it is one of their food plants, but they feed on many other trees as well. Then you have Ciconia nisamaya at the top. This is an important thing because it has actually moved on to feed on black bottles. And because of that, it has expanded its range quite tremendously. And we hope that it will continue and eat more black bottles. Then you have Nuderelia cytherea, the so-called pine emperor. Caterpillars feed on Proteaceae, but they will also go onto pine. And this is typical of very often, just because a few of them have been found on pines, they are now called a pest. In fact, I wish they would eat more pines, but unfortunately, they are normally only on the proteus. And then you have Lobobunea ancasana. This is the largest moth found in Southern Africa. Interesting, like in many other moths, you often have very distinct larval morphs. This is Holocerina smilax. And all three of those caterpillars are different morphs of exactly the same moth. Then you have the Ludias and the Vegetias, which are rather rare, localized moths that you find only in the Cape, fynbos areas. And just some more Saturnidae. So now I need to take a glass of water because I've been talking too quick, and I hope I have not lost all of you yet. But we shall continue because wading through a mega diverse fauna is not always that easy. These are the Geometroidea, the geometric moths. They are known as Geometridae or loopers because their caterpillars have lost all of their prolix. I'll just go through some of them. And therefore they loop and they measure the earth. And that's where the name Geometridae comes from, because they actually measure the earth. There's one small family, the Cematuridae, with a number of species in the neotropics, and we have one species in Africa. And this is a fast-flying diurnal species that is very rarely seen. Then we have the Uranidae. True Uranidae are not known from South Africa, but this is an example of Chrysoridia crucis that lives in coastal Mozambique. But we do have the Microninae, and here are two nice examples of, they're sort of mostly white moths with tails, and many of them have become diurnal. Then we have the Epipleminae with 17 species. These are quite spectacular because they roll up their wings, and especially their forewings, and they have these rather interesting, bizarre resting postures. The caterpillars feed on various types of Rubiaceae, and they are found in just about all parts of Southern Africa. Then we go to the geometrids proper. I'm just skipping some slides of some research work where we're trying to understand how they are related to each other. And we get to this group called the cycad moths. They are quite interesting because they moved off from their common ancestors that are fern feeders, and they moved on to feed on cycads. And by doing that, they developed the ability to sequester the toxin macrozamin in these cycads, and this has allowed them to become unpalatable to predators themselves. Now, they can't make sounds to warn bats, so they have become diurnal, and they therefore develop warning colors. The warning colors often differ depending on which area they are found. This is just another slide which we won't go into now of their relationships. And this is one of their closest, nearest relatives, Argyrophora. And the reason we put in this slide is to show that you get these allopatric populations of these species, and they all seem the same. But now that we are doing their sequencing their DNA, and we're having a closer look at their morphology, we see that we actually have a complex of cryptic species. And once this has been fully investigated, the diversity will increase even more. Then you have the Drepanoginini with 311 species, mostly in the mega genus Drepanogenus with 170 species, but which we are in the process of breaking up into 7 distinct genera at the moment. These are extremely interesting moths because they are almost exclusively Southern African. There are a few species that have migrated up north in fynbos and fynbos remnant habitats into the rest of Africa, but primarily these are South African geometrids, and many of them are very restricted in range and probably threatened. These are the Sichiodes, which we will change to Sichiodes from Drepanogenus. They are unique within Drepanogeninae because they feed on Celostraceae, and they actually have multiple generations because the food source is readily available. But most other Drepanogeninae actually feed on Asteraceae, and they occur in mostly arid Southern Africa, where rainfall is unpredictable. And they've developed a very unique mechanism of the caterpillars being able to go into a dormant state anytime when the food source is not available. And therefore, these adults only appear once a year because they are univoltine. They only have one brood a year, and the caterpillars take their time and can just sit there for months waiting for food if the weather does not allow them to continue. I'm sure you have seen many of these. We call them now Axiodes. They are rather cryptic things confined to fynbos and karoo and remnant habitats of that nature, where most of them feed, as I said, on Asteraceae. In fact, we now understand that many of them exclusively feed on rhinosterbos. Previously, it was not known of any of Lepidoptera feeding on rhinosterbos. Here, this is one group within the Geometridae, which are winter moths, and they are true winter moths. They will only come out when the biggest cold front comes over in the extreme cold. And you can see by their thick fur that they are well adapted to that. And it's actually a good survival strategy because which self-respecting bat will actually be out at that time? Here we have some more examples of Drepanogenus. At the one in the center is quite interesting because it rolls its wings up in an unusual fashion for Drepanogenini. So we continue to the Boarmini. These geometrids are rather interesting because they are unusual that they feed on many different plants, and they are generalists and generally found most commonly in forests. Here's an example of some of them, and you can see on how many different plant families these caterpillars actually feed. Then we have the Macarini. These mostly feed on thorn trees, Senegalia and Vachellias, and are most common in bushveld areas. The one in the center, Acanthophylla focularia, we don't know what it feeds on, but it is the females have become diurnal, but the males remain nocturnal. So we shall continue. I'm almost up with my time, so I'm going to now run through some of these groups and not talk too much, because then we will not finish this. And the main aim of this talk is just to actually throw into your face this absolute amazing diversity. So we just go through some of the geometric groups. They are mostly cryptic. There are some that have become diurnal. And you will see this diurnality coming through very often in all the different moth groups, because it's a survival strategy that allows those that have sequestered toxins to protect themselves. The rest of them are often very cryptic. These are the green ones, the Prasidiochymas. You can see the caterpillars of these things are extremely cryptic and very difficult to see. There are some more of them. These ones are interesting in that they actually attach debris from the surrounding areas onto their bodies, and each one has a unique, bizarre shape. There are some more emeralds, the green moths. The ones on the top feed on Passerina. So we finish with Geometry Day. These are the waves, amazingly interesting little moths. You can see the diversity of patterns in them. This is a very special one because during the day, in summertime, they are nocturnal, and in winter, they become diurnal. So you have both diurnal and nocturnal moths in one species, depending on the time of the year that the broods are out. There's some more examples of waves. As you can see, this just continues, and I'm running out of time. So I'm just scrolling through these things, and just cast your eyes on the diversity of pattern. And you will see why this has fascinated me all my life. I always wanted to know. Now we come to the Gellichioidea, the curved horn moths. These are tiny moths, each one with its own life. This one it makes a shelter by folding the leaf. It does not feed in the shelter, but feeds outside of it. But when predators like these ants come, it jumps down on the silk, on its own silk, and when the ants disappears, it pulls itself back up into its shelter. And this way, each species of moth has its own unique survival strategies. We just don't know what they are. These are the Ephmeidae, also make sounds to warn bats that they are toxic. These are some more nice examples. You can see the curved horn, which is really a characteristic of Gellichioidea. You see some more examples. These ones are in the Cape where they feed on Proteaceae. So we're really running through these quite quickly, just to give you an idea of the diversity that actually exists. Some of them have extremely bizarre shapes like this one. And we quickly go through some of the Papilionoidea. And of course, butterflies are only a small group of moths that people call butterflies. And these that are traditionally called moths are actually also in the Papilionoidea. And then we get the pearl moths. They are really beautiful little shiny moths with pearly sheen on them. Many different species. and many stories to tell if we have the time to do that. You can only sit back and be amazed at the form and of all of these things and its endless forms. Then we get to the Pyralidae, the Phycetinae. We have Alucitoidea, where the wings are broken into feathers. You have the Pterophoridae with beautiful caterpillars. You have the Cossoidea, which are the most long-lived moths. Caterpillars can last up to 10 years before they pupate. And Betabellidae, which are not very well known. You have the Ciceids that look exactly like wasps. You have the Zygenidae, the slug moths, the Limacodidae with caterpillars that you should not touch, and beautiful forms. You have Protodactylidae, you have true burnets, you have Tanaid moths that feed on everything but plants. These ones feed on bat guano. You have the Psychidae that make these bags, the bagworms. You have the Epihallidae with Litovenus, which is quite famous, which are some of our most primitive moths. And that is how it goes on. I'm afraid that I've run completely out of time. But if you want to know more, please buy the book and take your time and peruse them, not in the way I did now, but look at each one as an individual species in its own right. Thank you.
Wow, Hermann, thank you so much. I think I'll just echo the sentiments in the chat group of people just saying thank you so much for all the information and the massive amount of work, and they are enthralled by the absolute diversity and immensity of this fantastic group of fauna. So thank you so much for sharing your passion and your knowledge with us. And it is a pity that we had to rush through it all. But as you say, if people want to get more information about it, the book is definitely the way to go to take your time going through it. If we can get onto some questions, if that's okay, I will open up the box here and let's see. Steve, he says in the book, I'm going to try and pronounce here, that the diaphone in Mulier is in the Hadenae group, not the Nocturniae. Has something changed?
What, the diaphony?
Mm-hmm. He said
yes, it's something we need to sort of, you will see that a lot of chopping and changing going around in recent years, and that is because traditionally we try to understand the phylogeny, in other words, the ancestral relationships of these moths through looking at the morphology. And we find things we call synapomorphies that show specific characters common to a certain common ancestor. And the taxonomy is built to reflect that. But in the last couple of years, with molecular sequencing becoming easier and cheaper, from the genes, we are learning a huge amount of new things about the actual natural relationships of these moths. The unfortunate thing is that the taxonomy keeps on changing. And you will see these chops and changes going all the way. What you see in the book is the situation as it was a year ago, because that's when we finished the text. And this will continually change, because the taxonomy must keep tred with our current understanding of the phylogeny.
Fair enough. Two questions from an anonymous person here was, does the crimson spotted moth live in Southern Africa, and do woolly bear moths live in the Arctic tundra?
I don't know what a crimson spotted moth looks like, so it probably does not occur in Southern Africa. If woolly bears living in Antarctica, I am not aware of anything like that ever being recorded in Antarctica.
Interesting. And then what does therma in the therma mean?
What does?
What does therma in philotherma mean?
To be quite honest, I don't know what the author actually meant by that. It can mean many different things.
Right. And then why is, Carolise has asked, why is there a trend towards becoming diurnal?
You will find that in most cases, the movement to diurnal is a response of the ability to sequester toxins from the host plant. As soon as a species has developed the ability to sequester these toxins, then there's a huge, it's easier to warn predators by color than by any other means. And this is away from escaping bats, probably.
Wow. Terry has asked, this he just said mind-blowing in this, it is wing rolling at rest state found in some families as a result of the convergence or multiple origins?
Yes, no, they are multiple origins, and you will find it repeated in unrelated fauna.
Okay, great.
So, yeah.
Mark has asked, thanks for the great talk. And how often do you find parasitoids emerging from caterpillars?
That is a very good question. I combined the caterpillar rearing effort of myself and Ian and Alison Sharp, and out of 3,000 rearings, 20% of the caterpillars were actually parasitized.
Wow.
So the figure is around 20%.
Fantastic. Thank you. Great question. Terry is asking another one. Sure, you're making me battle up all these words. The Toitorosoides occur in Southern Africa, or did I miss it?
I just repeat that.
Do Toitorosoideae occur in Southern Africa?
Yes, they are, in fact, one of the groups that I didn't touch on at all because we just ran out of time, and they are small and cryptic. But previously, they were thought to be only a small family of maybe 60 species. But we know today that they are the dominant fauna, and there are literally hundreds of undescribed species that we are rearing in the caterpillar rearing group at the moment.
Fantastic. Carolise has another question. Yeah, are moths bothered by how light the nights have become due to light pollution?
Yes, that's also a very good question. Certainly, light pollution is one of the major threats to moths because they get taken out of their natural habitat. And if those lights stay on, they actually get lost to the biodiversity, and it becomes a drain. And when we put up moth traps in nature reserves in the middle of urban areas, then we see that there's a huge drop in the diversity, even though the plant life in those nature reserves are still there. And we think that this is as a result of light pollution. It's a major problem in Europe. It's a problem in the UK. One of the unintended consequences of modern lights is actually a good thing, because LED lights attract much, much less moths than what the traditional light things are. So if you really want to do something, replace your lights with LEDs. In fact, many people say all of a sudden they lost all the moths because they don't come to their lights anymore. Then I say to them, did you change to LED? And they said, yes, and that's the reason. So that's really a fantastic unintended consequence. Please change all your light to LED for moths.
Wow, that's great. Ian Barber said, I occasionally come to Southern Africa for work, was there just over 3 weeks ago, and have pictures of 300 plus moths. I'm looking forward to seeing the new book to try and ID them. But to who would I submit my records if he wants to let people know, get records of what he's photographed? Where would he be able to do that? Or is there a need for that?
There is certainly a need for that. And the best place is to actually put them onto iNaturalist, where people will then identify these moths. And if enough people have identified it, often these identifiers will come to me if they really struggle. And these data actually come into our databases, and they help us understand the distribution of these moths. And ultimately, they will help us understand when we do conservation assessments.
Fantastic. Colin has said he loves photographing nature. Any hints of getting moth shots? They always seem to shoot off when approached. Your presentation pics are also professional. Any hints for photographing the moths?
Yes, probably the best way if you really want to photograph moths is to try and do them in their natural settings. So what I do is I put a tent, like an umbrella with gauze around it, and I put the light inside, and I put the tent on top of vegetation, over a bush or something like that. And this will attract the moths to go inside, and then they will settle naturally on the vegetation or underneath, and you will quickly learn which will settle on the leaf litter, which will be on the stems, which one will be under the leaf, and there you can photograph at leisure in as natural a setting as possible. And you will see all these pictures in the book, and they were actually taken in this type of way.
No, that's fantastic information. When just you do the talk about this mega group and the diversity, what is, from my side, what is believed or what is understood to have created this level of diversity? Why do we see such a level of diversity in the moth species, the moth fauna, as opposed to sort of other species, the vertebrate and all that? What has allowed this diversity to happen? Is there any understanding as to why?
There are, of course, a number of different hypotheses, but there are some important factors. Firstly, that they turn over their populations much, much quicker than humans do, for instance. Many of these moths will have 5 or 6 generations in 1 year. And if you combine that with their long history, they have been around for at least 185 million years. Then they have had a lot of time to actually speciate. But on top of that, and this is vitally important, that they tend to specialize. Moths don't feed on anything they like. They normally specialize with certain plants, or they are habitat specialists where they will only be found in one certain type of micro habitat. And when the climate changes, these habitats fragment. And these are ideal speciation factories. And that's probably one of the reasons why these insects are so diverse.
Well, Hermann, thank you so very much. I think we've come to the end. That's the end of the questions that I can see. Just from the chat box, so many people saying thank you, wild, inspired. Thank you for the information, for the talk, and for your passion. And I'd like to echo that. Really, really appreciate you talking to us, and we'd love to have you back again and go on a more meandering journey through this fantastic topic. Thank you to Belinda, and thank you everybody for joining us. We will see you on the first Wednesday of December for our final talk. Thanks everybody. Thanks Hermann. Thanks Belinda.
Thanks. Cheers.
Bye. Bye.